my name is Verdan Mahmood. I am from Pakistan, currently living in the Netherlands. I'm working for ING Bank, and my speech topic is data discovery. You can think of this as the Google of data. According to research, that scientists spend up to one-third of their time in data discovery. This is not what that scientists should focus on. Instead, they should focus on analysis work. I will be talking about why effective data discovery is so important and what solutions do we have for this. Thank you for watching. Good morning, folks. My name is Verdan Mahmood, and I'm a software engineer at ING within the wholesale banking advanced analytics team. I'm based in Amsterdam. Today, I will be speaking about our journey around data discovery and data lineage using Apache Atlas and Amundsen. First, let's talk about why effective data discovery is so important and why are we even talking about it today. This is the mission of our team. We want to build algorithmic 10x data-driven products that benefit our clients and at the same time generate revenue for the bank. The goal is ambitious. The whole vision is really ambitious. And data is the only way to make informed and objective data-driven decisions. Not just that, security, GDPR. We are a bank. We have responsibility. So we need to understand, where did I get this data from? What is the latest version of data that I'm using or that I need to use? What does this data contain? And so many different questions around the whole security things. And this applies to many roles, by the way. So suppose for the data scientists, analysts, they need this information for the exploration purposes. Engineers like myself to verify the choices we are making in order to have the desired impact. Business managers, even product managers to generate the reports for the target marketing. And this is how the whole data-driven decision-making process look like. It can be divided into 4 major steps. Step 1, you would search and find the data. Once you know where is the data, step 2 is to understand that data. You need to know what does this data contain. Afterwards, at step 3, you perform an analysis on that data, or maybe generate some visualizations, some nice charts or dashboards around that data. Finally, at step 4, you would make a decision using your visualization or analysis work, or maybe share your insights with the stakeholders. And you can clearly see that half of the data-driven decision-making process is actually data discovery. Let's take a hypothetical example. So suppose you are a new data analyst in the team and you want to work on a super impressive feature on fraud detection. What are the challenges for you? You need to know what data to use, where is the data, who is the right person to contact to know about this data, but so many different questions. Let's talk about the challenges. Searching and finding the data. How would you search the data? How would you know what data to use? You would ask your friend in the team. You would ask your co-workers or even your manager. If no one has the satisfactory answer, what would you do next? You would send a message in the Slack channel, or perhaps in the wider Slack channel, in the general channel, to know if someone has the right answer for you. Even if you don't really get the desired answer in the Slack or whatever you're using in your organization, you would simply search in the Git repositories then. You would try to search the data that you need all by yourself. And if you're lucky enough, at the end of the day, you would have some results, you would have some data sources, or even multiple data sources. Then the next challenge would be to understand that data. Which version is correct? Which data source is up to date? Am I looking at the outdated data? So these are the next challenges for you. What do different columns mean in different data sources? You don't really know this information beforehand. How would you try to solve this problem? You would try to look into the data itself. You would start using SQL queries or perhaps the static query to get the complete information. But you know, this is really expensive uh, information, right? According to research, data scientists spend up to one third of their time in the data discovery. And this is not what data scientists should focus on. Instead, they should focus on analysis work. If they are spending 30%, almost 30% of their time just finding the data that they need to do their job, that's incredibly frustrating experience for them. And even it is a drain on resources for the company. So if I would try to summarize the whole thing, data discovery is a problem because of lack of understanding of what data exists, where, who owns it, and how to use that data. And there are three different horizons of data discovery. The search-based, where is the data? What does it contain? Has anyone already performed some kind of analysis on this data that I can use for my work? Lineage-based, I need to know this information because I need to know what data sets are linked. So suppose if the event is down, what data sets are going to be impacted because of this? This is completely lineage information. The upstreams or the downstreams. So suppose if the table delivery is delayed, I want to notify all the downstreams because like, hey, this table is going to be delayed. Final is the network based. Who are the frequent users? Because maybe I want to follow a power user in my team who has the complete inside picture of the data. What tables my team use? I need to know this information because that would definitely be helpful for my work. I want to bookmark tables of interest in order to get the feed of data delays or notifications about any kind of schema changes or any kind of incidents notifications. Enough with the problems. Let's talk about a solution. Amundsen is a solution. Amundsen is an open source application, data discovery application, which was initially developed by folks at Lyft. They later donated the whole project to the Linux Foundation, which is operating as a central governing body for the whole project at GitHub. By the way, Amundsen was the first person to explore both North and South poles. I will be talking about the UI first of the Amundsen, and then I will try to explain the architecture of Amundsen. But first, let's just go to some of the screenshots that I took from the GitHub. By the way, a disclaimer here: all the data that I would be showing in the screenshot, that's a dummy data. That's not really the real data. The first screenshot is the landing page. So once you go to Amundsen, the first page that you see is this page. And you can clearly see that this is optimized for the search. You have the big search bar on top of the page. We also introduced a nice concept of popular tables. This is basically to be able to help the people who don't really know what to search for when they come to the Amundsen. And when you start searching for something in this search bar, you'll be seeing some results which are ranked on relevance and popularity. I will be speaking about relevancy and popularity next. Relevancy is pretty straightforward, like finding the results which are related to what you search for. So suppose you search for apple on Google, you'll be seeing the apple as a fruit, not the oranges, because apple as a fruit has high relevancy. In terms of popularity, this means is when you search for something, we want to be showing the results that people are more often looking for. So if you would search for Apple on Google, you should be seeing Apple as a company because that has high popularity rather than the apple as a fruit. And striking the balance between the relevance and the popularity has been a very interesting challenge. So relevancy is basically based on the pieces of metadata like names, description, tags, frequent users, and we have assigned different weightages for different pieces of metadata. Popularity, on the other hand, is based on our queuing activity. So suppose if there is an automated process, an Airflow job or a cron job making queries on a data source that would have the lower weightage as compared to an actual user who is making queries on a data source. When you click on any of the search results, you will be seeing this page. This is like the view resource metadata. In this example, this is the table detail page, but you would have the dashboard pages or so many different kind of entity pages. You would have the list of columns on the right hand side, along with their data types like strings or integers, float, or things like that. And on the left hand side, you would have the different metadata information like description, associated tags. You would also have the date range to give you understanding from which date to which date the data contains in this data source. You would also have the information about the frequent users and the owners, so you know at the end of the day who you should contact in order to get the insights about the data. It also has the preview button, which you can configure because yeah, using the configurations to see the top X number of rows, let's just say, of the data source. To give you example, like what is the structure of the data. You also have the badges on top of the page, just below the table name. These are basically non-editable, auto-generated tags. So if you would click on any of the column, you would have the computed metadata statistics. And the reason why this is so important is because it would give you the insights about the data, the quality information about the data. So suppose if 50% of the column rows are null, then you know that you don't really want to use this column for your work. So this is the high-level architecture of Amundsen. Amundsen is based on the microservices architecture with three main microservices: front-end, search service, and metadata service. The search service is backed by Elasticsearch, and metadata service is backed by Neo4j in the default version. And there is another component, which is the data builder ingestion framework, which pulls in the information from different metadata sources and inject that information in Elasticsearch and at the same time in the Neo4j. Both search service and metadata service are the thin proxy layers, which are written in Python and can be switched easily between different backends like Neo4j or Atlas or Gremlin or any other custom backend or metadata store. So if you are on the landing page of Amundsen and you would search for any kind of data source, those requests would be served by the search service. And if you would go onto the table detail page or resource metadata information page, those requests would be served by the metadata service. That's the default architecture of Amundsen. What we did at ING, we replaced Elasticsearch, Neo4j, and the data builder with Apache Atlas. In our case, Atlas is a single store of metadata and lineage information that integrates nicely with the other metadata sources or the open source technologies that we use like Hive, Spark, S3, Ranger. It has the hooks and bridges, um, another different types of entities information that can be used to integrate with the other components. The next topic is the data lineage and metadata. But first, why are we even using Apache Atlas? Why not the Elasticsearch or the Neo4j? So in our case, Atlas is like the data governance solution. It is an open source backed by the community, and it has the metadata types and instances already supported with it. It has the predefined types for various Hadoop and non-Hadoop metadatas. Um, it also has the hooks and bridges, like for HBase, Hive, Kafka. So you, at the end of the day, you would have the push-based model, not the pull-based model. If I would try to explain the pull-based model, it's like you would have the data builder or Airflow DAGs or cron jobs to pull the information from different metadata resources, while in case of Apache Atlas, it is already connected through the hooks and bridges with the different system. So you don't really need to write those cron jobs or DAGs to pull in the information. Instead, every time there is an event, it automatically updates the Apache Atlas. It has the complete lineage of data as it moves through various processes, and that's the out of the box support. You don't really need to do anything yourself. It has the support of classifications, tags, so entities can be associated with multiple classifications. So you can apply different kind of ranger policies based on the tags. By the way, yeah, one main feature of Apache Atlas is security and data masking. It it integrates very nicely with Apache Ranger, and you would have at the end of the day fine-grained security for metadata access. It has a powerful graph engine for search indexes, and on top of that, it has the REST APIs to work with the types and instances. You can use the REST APIs to work with most of the features of Apache Atlas, like lineage, assigning tags, assigning different policies, searching by complex criteria. And those REST APIs actually helped us for easier integration with Amundsen. This is the overview of how we are using Atlas and Amundsen at ING. So a data scientist or an engineer or anyone goes to the Amundsen, which is backed by Apache Atlas. And we are filling in the information of popularity score and the data lineage and metadata. I talked about the popular tables in the first page of Amundsen that are actually based on the popularity score. I will try to explain those two components, popularity score and the data lineage and metadata information next. First, the data lineage and metadata, how we are storing this information in Apache Atlas. We have a self-written application, a framework that we call generic data ingestion framework that we use for most of our purposes. So how the whole process look like? So the data owners describe their data sources in the schema registry, and our ingestion framework reads the schema and data source properties from the schema registry and creates the Hive tables and populate the metadata information in the Hive meta store. I explained earlier that Atlas has the hooks for the Hive metastore. So using that hook, Apache Atlas automatically gathers that information and stores in its own database. Our ingestion framework compute and save data quality metrics along with the data sources in the Apache Atlas. So these are the two screenshots of Apache Atlas. On the left-hand side, it gives you the information of the metadata. You can have your own custom fields, custom properties in the different forms like JSON or list or dictionary, key value pair. And on the right-hand side, the screenshot shows you the lineage information of the Hive table partition. It has the different sources, and at the end you would see like, hey, how this partition is impacting the whole data. In terms of popularity score, we leverage the ranger audit logs. So again, um, we use Apache Ranger for the authorization. So every time someone runs a SQL query on any of our data source, Ranger keep tracks of those queries and manage access and audit logs of the querying activity. And using those querying activity, we calculate table popularity score and then store that information in Apache Atlas. In our case, the formula for popularity score is number of distinct readers multiplied by log of total number of reads of that particular data source. In the bigger picture, we are a part of data analytics platform. The whole Amundsen Atlas is a part of data analytics platform. Uh, DAP, Data Analytics Platform, is a cloud-native platform for data democratizations, and it was created to speed up the experimentation done by data scientists and analysts. And most importantly, it was developed internally within ING by Wholesale Banking Advanced Analytics team. It has four main components: front end, compute, storage, and security. So on the front end, we do have the front user-facing components like Portal, Jupyter Notebooks, Jupyter Labs, Superset, or Amundsen for the data discovery. And on the security and integration, we do use Vault, Keycloak, and Apache Atlas, Apache Ranger, and Airflow. Some of the main features of DAP are that the whole platform is horizontal scalable, and it was built using latest open source technologies. And of course, it has end-to-end security throughout the whole platform. We are open source advocates. We don't just consume open source application. We try to push everything back to upstream as much as possible. Again, I mentioned about the search service and the metadata service of of Amundsen. We made the proxies for Atlas. We created two different Python packages to make it work. One to create the entity definitions that we need for the Amundsen, and one is the PyAtlas client to connect Atlas with Amundsen using the REST APIs. And everything is completely open source and is available on GitHub. So these are some of the prominent users or the active community users of Amundsen. Um, as we speak today, there are many of the organizations who are using Amundsen in their production environment, and many of them are still exploring of how they can leverage the whole Amundsen for the data discovery and data governance. I'm really proud to let you guys know that ING was the first company outside Lyft who deployed Amundsen in their production environment. And we have been working with the Lyft guys since the inception of the open source journey of Amundsen. Finally, about the wholesale banking advanced analytics team, we are based in four different countries and many locations: Romania, Poland, Netherlands, and England. We are multinational team. Finally, I really want to thank Mark, who actually helped me with the lineage and metadata section of this presentation.